incredible conversation and comedy, okay, which we love. I'm so grateful to the Apache entire project. So today, everyone, my name is Nyah Macklin. I'm a senior developer advocate at Neo4j, and we're going to be talking about how to architect your context in order to make your agents much smarter than they are. And, okay, I'm adding this little point at the end so that you can not end up in court, okay? We don't want to be in court because of these agents. So let's dive in. So again, if you want to follow me on LinkedIn or talk to me about anything with regard to graph or context, you can find me there. My research focuses on graph theory, graph algorithms, context engineering, but I also study ethics, governance, and responsible artificial intelligence. So we can have a separate conversation about that anytime. And then all the things about me as well. So, but let's dive into the real stuff. Okay, so I first want to start off with a question, right? So what happens when dozens of AI agents actually have to work together? Is it calm? Are there no problems? We know, yeah, it's never like that, man. It's never like that, right? So in reality, when you simply unleash a number of different agents, that they have to just find out how they're going to actually try to work together, right? To either solve a user-defined problem, maybe some are trying to cooperate on a specific task, and then others, some just need to stay out of each other's way, right? So there's a large risk of when you unleash lots of AI agents, they start to look something like this. Okay, chaos in the skies. Thank you for that one chuckle. So chaos in the skies. Here I have a picture of air traffic control just telling planes to do whatever, right? Do whatever, figure it out, land that plane, maybe don't, run out of gas, who knows, right? But it's your job to figure it out. So the same actually goes for agents. So when they work in swarms without structure and orchestration, it can often be madness, okay? So we see now that many studies are coming out that are looking similar to this, right? 95% of AI agents are failing. And that's a study done by MIT. I have the QR code if you want to read it yourself. 2025. And so if 95% of AI agent projects or pilots are failing, like that's a lot of wasted money, right? Like we're trying to scale all of these several AI agents together as well. That money that's being wasted is multiplied. So how do we stop that, right? Let's freeze time. Why are these agents failing? So what we're finding now through our research is that AI agents are often failing because they don't have this concept of context. And many of us know that, right? We're all context engineers ourselves. But AI agents don't have this common knowledge that's tying them all together so that they can work more harmoniously. And the missing ingredients that I found is actually context. And so I want to get into quickly the past, right? The past, context engineering. I'm saying context engineering was the past, all right? So who can define context engineering for me? Oh, come on. I see one or two in the back. All right, go for it. Go for it. Yep. Interesting. So you have, I heard a prompt focus, giving it the proper prompt. I would argue that that's prompt engineering, but you would argue that that's context engineering? Okay. Yeah. I can respect that. I can respect that, yeah. So I would often define context engineering as a system, specifically, of systematically providing models with the relevant information, with the relevant tools, right, and the relevant instructions and prompting as well, at the correct format and also at the correct time, okay? This is very important in order to complete a particular task. So I'd like to say that that's slightly different from prompt engineering, where you're trying to use the right combination of words in order to get your LLM to say something very specific. Context engineering centers on building dynamic systems that completely assemble that context and that structured context as well for each LLM invocation. So this is a shift of focus from cleverly worded prompts to actual comprehensive contextual design. So that's why context engineering in general has become like a really critical skill for AI engineers right now. And there are many different facets of context engineering as well, right? Several different techniques that practitioners can use in order to improve the contextual relevance of your agentic development. And I'm not going to dive into these. I have a whole nother talk where I dive into all these for those who are new to context engineering, but that includes like naive RAG, which I've represented here. So I used to be a teacher, so I like to give people visual cues so that they can remember different concepts. So I have here, like, how do you do, fellow kids? It was like the OG way of doing RAG, like the old one. So we have naive RAG plus hybrid search. I think those two together would involve and improve context engineering. I also have here memory management, which I have represented by Dory. And that's just when you're using memory management, you are trying to decide for your agent, what are you actually going to forget? Okay, that's the key. So Dory was such a forgetful fish. You tell her something, and then the next second she'd be like, what are you talking about? Who are you, right? What's your name? And so for memory management, you are trying to manage what things am I actually going to forget within my context? And that's a concept. That's a technique for context engineering. I also have here structuring and ordering of your context. So most of us know, right? Anthropic, for example, has a number of guidelines regarding to this, but we all know that we put our most relevant information at the top or at the bottom of your context. At the top. At the top. Excellent. Right. At the top of your context. And then here as well, we have tools and function calling. So instead of just stuffing your context window with all of the information, you're just going to give it all the data, right? And you're like, figure it out, right? Instead of doing all of that, we can actually do tools and function calling. So I have that represented by MacGyver. Those of us who are a little bit older might know. You youngins, go away. But I have MacGyver here. He was a guy who always had a tool to fix anything, right? To fix any problem. So I have tools and function calling here. And then lastly, we have knowledge graph augmented context. And I'm going to get into a little bit of that today. But where you're using knowledge graphs to cement your context as a representation of all of your data. And so normally, to overcome the AI's black box problem, we need knowledge to actually be transparent, right? We see that this here, where I show you a human view of an apple, right? We have a red apple in the center, and then I want to show you the vectorized view of an apple. I don't know who has memorized the vector view of an apple. No! Obviously, this computer hasn't, but let's try to put it back together. It's okay. We'll try one more time. But all in all, you saw it's just a whole bunch of numbers. And perfect. Thank you. So we have the vectorized view of an apple, a whole bunch of numbers. It's an embedding. It's not human readable, right? It is machine understandable, but it's not human readable. And so unless you've memorized the vector of an apple. And then on the other side, we have the knowledge graph view of an apple. So what's interesting about the knowledge graph view of an apple is it's both human understandable and machine understandable. So we can see here, we have an apple, which comes from a tree, right? That apple also has a specific body or specific look. It's round. It's a fruit. It's not the company. We're not talking about the company here. Knowledge graphs make what can be understood as humans by humans and machines, and then creates a fusion of both, which is very, very interesting. So most people right now, for example, we're using OG RAG, that native RAG, vector-based RAG, and most people are structuring their data in tables and rows. So you have to do, if you're trying to understand the complexities and the relationships between your data, you then have to do a whole bunch of complex joins in order to see how things are related. And that can then also drastically slow down the performance of your agent. But if you structure that same data as a knowledge graph, then you can start to see the relationships and the connections and the groupings become much more clear. So now your agent can specifically hop from one node of information to the next and be able to trace, right? To be able to trace and explain where it went for its answer. So I'm not going to get into this, but that's just an idea. So now we're talking about the present. Okay, so here I have in the corner this seminal paper that had just come out a few months ago. It's called AI's $1 Trillion Opportunity Context Graphs. Has anyone read that paper or even heard about the wild paper that went around? Okay, I see a few head nods, but not a lot. But this paper went wild back in December, and it's been making its waves. It was done by a VC company, and specifically, it's talking about this idea of context graphs. So it's not necessarily this change of terminology, but it's actually a slightly different focus. So this particular paper was articulating that agents are missing not just the what, right, but the context itself, but also the why, right? The why behind the decisions that agents are making every day. And when building agents, we need to have this specific decision trace that is auditable and trustworthy and more explainable. And there, I also have a number of different white papers that you can read. Perfect. I saw people with their things up. Don't ever believe someone who's on stage telling you about the things. Read the white papers yourselves. But it's shifting that understanding from agents, because now agents are not just like answering quick questions for us. Now agents are actually making decisions about our lives, right? They're making financial decisions about our lives, whether we get access to money, access to loans. They're deciding our medical use case. Agents are doing all of that work. So because of that shift in power that we're giving agents, we now need those agents to be trustworthy and to be traceable and auditable. So context graphs specifically provide this missing why. Like I had mentioned before, agents have no memory originally, right? An agent, you ask it about last week's conversation, it don't know what you're talking about, right? It has no audit trail when something goes wrong. No one knows why that agent decided that. You can't just say, honey, I don't know, the agent said so. That's not going to work when you're on the job. And then there's also no shared learning. So if you're deploying multiple agents, then they can't share what they have learned. That's a common issue. So context graphs as a concept, and I know a gentleman had shaken his head, he had heard about this. Context graphs as a concept, they're fundamentally knowledge graphs that contain all of the information that's needed to make decisions throughout an organization. And then this differs from simply opening up your agent to an audit log, for example, right? Like, which would then have a line-by-line transaction history, but your agent now is going to have this breadth of information from Slack messages, from email chains, from Zoom meetings. All of that information is connected in this graph, which can show you the full context and the full why a single decision was made. So this now includes things like causal chains and decision traces that actually can be queried, right? And then traverse to ensure that your agents are more reliable and trustworthy. So I'm going to show you a demo. I don't know how much time we have. A little bit. I have a financial services model here. Anyone work in financial services themselves? Two. That's okay. If this was in New York, this would be full of financial services folk. But in this data model, where we have these things called entities, it's really just people, places, and things. And then we have these events as well in this data model, things that happened, the what. And then lastly, we have the context, which is the why, the decisions, the policies, etc. So that's the simplified model. So I want to show you the demo. And this is a live demo as well. It's hosted, so you can go to the demo and you can test it out yourself. But here, if we were to go, and just a quick conversation about this schema as well. So let's make sure that people can see it. So we have a person here. So this is the actual schema. We have a person. This person is, and you can move this information around. This person is connected. I really can't see it from there, so I'm just going to try and see it on my own. Okay, so we have a person who submitted a specific support ticket about a specific transaction. Again, this is the financial services model. And that transaction had triggered an alert, which then flagged the entire account. And so that alert then took into context the entire system that then caused a decision to be made, right? Which was based on a policy. And then that decision was communicated back to the person who owns the account in the first place. So let's actually, and I'll scroll out for you all so you can actually see. Let's run a query. So we have a query, and these are just sample queries. Again, this is open source. You can change it yourself, all for free. We're going to run a query here, and we're going to see what's happening. So here we're asking the agent, should we give this client, Jessica Norris, a $25,000 credit limit increase, right? So should we do it? You're a bank analyst. You can say YOLO. feeling generous, Jessica. You're welcome. Okay, I'm gonna just give you that $25,000 credit line increase. Let's do some vibe banking today, okay? Y'all don't want vibe banking? Y'all don't love that? Well, that's what you're doing when you're giving your agents autonomy to do whatever they want. Okay, so stop trusting your agents without that context. But if we inspect what our agent is doing throughout this process, we can see that we have a defined number of tools that, that your agent is using to interact with this entire context graph. And we have a system prompt, as well as the specific tool calls that make your agent fetch the data with the context that's necessary in order to make a specific recommendation. And so we see here, we actually can see the causal chain of what happened. We see the entire decision trace on the side, which would show us why we've decided to reject this request from Jessica. And what we see, and we can go in and read what it says. This looks super small. Oh, that made it so much worse. There we go. Okay, yeah, meat and potatoes. Okay, so this AI agent is saying that it recommends rejecting the credit line increase. And why? Because of actually this unsolved fraud alert that happened in May of this year. And how do we know that it could have been fraud? Is that this had 14 transactions in 29 minutes. It also had a geographic anomaly, and this agent has a 78% confidence that this actually was a fraud alert. No investigation that no evidence that the investigation has actually been resolved nearly 10 months later. And so we can see that that's just number one, the critical risk factors. And it goes down the list of the number of risk factors, and it's traversing the nodes that we had seen in the knowledge graph in order to gather all this information. So let's make this smaller. So yeah, so there's, we don't want to create agents that don't have that context and don't have the decision trace so that you can be able to audit your agents. This is just one example, but there are many. But let's go back. Let's finish up here. So how this all works. So if you look at how this agent works specifically, you can see that we have the decision trace history, how it's actually using the context graph. And then first it's going to search for the customer, and then it's going to, then for the context around that customer, you can see the nodes and edges like we had shown before. It was the circles and the lines to really show the relevant events, the relevant decisions. And then you can see that this transaction, what happened in the past, and then see actually, oh, there was a fraud flag that had just happened. And then after that, we're actually using hybrid search, which combines vector and graph search to actually do a lot of that heavy lifting. And I just wanted to give a little bit of information about this hybrid search as well. Hybrid search is what I had mentioned, combining vector and graph. I think that it's really, really powerful. Specifically at Neo4j, we use this thing called graph data science, which allows you to run graph algorithms like centrality or PageRank for those who know Google. But here specifically, we're talking about using graph embeddings like FastRP, if you've used that before, which is a generated embedding for context. And so it's going to then, after all of that work, do a vector similarity search, which allows us to find the policies and the decisions that are semantically similar. But it's then talking about the structure piece, right? We have that similarity search information that's coming from the vector, but we're missing this graphical structure piece. And so when you put them together, you get this hybrid system, which is the best for tracing down your decisions. So there's lots of background information about the exact things that are going on in this demo, what the exact embeddings are, what the architecture that we built out for using this, how graph data science helps with that specific tooling, and also what's on the horizon for agents and having those context graphs. So I see people with their cameras up, so I want you to make sure you get that, the architecture diagram. And if you don't get it and I click away, just come find me right after, because I'm about to click away. Boom. Okay, I'm so sorry, friends. But where do I learn more, there's so much research that's being done, not only on context graphs, but on graph RAG, graph algorithms, context engineering in general. If you want to learn more, please feel free to go to graphrag.com/appendices/research. This is our plethora of different, not our plethora, because we don't own this, but this is a plethora of different research and white papers that are done on these concepts that people have contributed to. So lots of information where you can learn more. And then lastly, I just want to make sure to plug Nodes AI, which is Neo4j's specific developer conference that we're having, which is happening on April 15th, completely free, completely virtual. So you can do it from your bedroom, okay, or your couch. And you can learn about artificial intelligence plus graph and the ways that it's benefiting agentic development. So I just want to say thank you all so much for today, for the speed run of a talk. I'm grateful, and I can't wait to see you again next time. Thank you. Thank you. Thank you.